Okay, statistics. So there are, statistics means that you are just collecting data and then you are analyzing that and using that for your research, or when you want to describe facts, then you are using statistics. What is biostatistics? When we apply the concepts of statistics to medical sciences, that is called biostatistics. So there are different branches. We are concerned with descriptive statistics. Why? Because we have to give results of studies, results of investigations. We have to describe them and we will give them in the form of data. So data is very important. It can be of many different types. So if we divide them, basically you are going to see three important types of data, like nominal, ordinal, then there can be interval data, and then there can be ratio. These four are basically used in the obstetrics, in the biostatistics. Okay, so what is a nominal data? Remember that nominal data is also called categorical data. It means names or categories that do not use or require an order, in which the same things should not be in a sequence. For example, eye color. You know that they can be different. Some people, they will have brown eyes, black eye, others will have black or blue eyes. So we don't have to say that brown eyes will be at number 1 and then black eyes. Okay, it doesn't work like that. Eye color, sex, ethnic group. So the values of the scale, they have no numeric meanings. They don't have any numbers. Then ordinal data, it deals with numbers, names or categories. And the data, they are ordered. For instance, pain score of 1 to 10, like you will ask the patient that if we give you 10 points, then where do you feel that you are having that much pain? Where do you stand? She will say like 5 out of 10, because she can tell you that she is having moderate pain. So the magnitude of the difference between the numbers is unimportant. Like one patient has pain at a scale of 2, the other one has at a scale of 6 or 7. So they are not the same. For example, the difference between a score of 1 and 2 is not necessarily the same as the difference between 4 and 5. Okay, and the interval between the adjacent scale values, they are indeterminate. So the difference between value 1 and value 2 can be, let's say that here is a difference of 10 points, and here between 4 and 5 there is a difference of 5 points. So it is not the same. The both values, they have a different gap, different differences, in the values. So it is not the same for all the cases. Okay. Then interval data. Here the data is ordered, like 1, 2, 3, 4, and intervals between adjacent scale values, they are equal with respect to the attributing we are measuring. For example, the difference between 8 and 9 is the same as the difference between 80 and 81. For instance, if you are measuring the shoe size and the difference between size 8 and size 9 is 1 centimeter, then the difference between size 80 and 81 will also be 1 centimeter. Okay, that is interval data. Yeah, any confusion, any problem, just ask me. So the difference between the values is going to be the same. That is the basic concept in the interval data. So then another type of data, ratio. Here again the data are ordered with mathematically meaningful interval. The ratio of the numbers is mathematically meaningful, and there is a rational 0 point. Whenever in any value you are starting with a 0 and you are going anywhere, you should say that this is ratio. For instance, if they tell you that there are two groups of patients, one of the patients in the first group, they live 10 kilometers away from the hospital, and in the second group, the patients, they live 20 kilometers away from the hospital. So here they have given you a reference point. So what is the reference point? Your hospital. So whenever you are starting from 0, you will say or you are using the same reference point, you will say that this is ratio. Type of data will be ratio. So there is a rational 0 point for the scale, and 0 actually means none, because if they will stay in the hospital, then they are not at any distance, they are going to be in the hospital, so that is 0 distance. Example is length or distance in centimeters, because when you are measuring the distance, for instance, you are taking the you are measuring a table. So what is your reference point? 0. You will start from 0 and you will go to maybe 100, so that will be the width of the table. So there is always a 0 scale. So nominal and ordinal data, they cannot be normally distributed, and their analysis requires non-parametric tests. Nominal and ordinal. Okay. What is the normal distribution? When we are all the values are going to be in a bell-shaped curve, that will be normally distributed. We will talk about that in a while. Then interval and ratio data, they can be analyzed by both parametric and non-parametric tests. Here non-parametric means that we will talk about them, that they are not comparable, they are different tests, the different types of analysis we will use. So what are the descriptive statistics? We use different values, like you must have seen mean, median and mode. So what is the mean? Mean means you will take the numerical middle, and or this is also called the average. What you will do, like in a study there are 10 values, and when you calculate them, like there are numbers 1 plus 2 plus 3 plus 4, so there were 4 values. Okay, if you calculated them, 1 plus 2 is equal to 3 plus 3 is equal to 6 plus 4 is equal to 10. Now there are 4 values, and if you will add them up, you will get 10, and when you will divide 10 by 4, you will get 2.5. so mean value will become 2.5. so mean means sum of all the values divided by the number of values. So for this, data must be interval or ratio. So this will be continuous data. So then another value is called median. It means middle of the frequency distribution. Okay, so half of the entries, they will lie above, and half of the entries will lie below that data, and for this the data must be an ordinal, interval or ratio. Like I will tell you this one, like you have 5 numbers, 1 2 3 4 and 5. Okay, so which one is in the middle? This 3 is the median value. Okay, so that is the median. It is the median when you have 5 numbers. Okay, now look at another example. Here we have 1 2 3 4 5 6. So now they ask you, so here they were uneven, they were odds, like you say in Arabic that they are tak numbers. Okay, because 5 numbers. Now look at this one, 6 values, so these are even, or you will say that you. Okay, so how you will take the number? You will take the 2 central values. Okay, so 2 central values, 3 plus 4 is equal to 7. You will divide 7 by 2. What you will get? You will get 3.5. Is it clear? Okay, so the median here is 3.5, and here the median value is 3. I have seen this question in your written exam also. 5 values, so the middle value is this number. 6 numbers are there, then middle values you will add the middle 2 numbers, middle 2 values, central 2 values, and then you will divide them by 2. Then there is another unit called mode. Mode means that this is the value that is reported most frequently for a variable, and this is valid for ordinal, interval or ratio data. I will give you an example. Like you have numbers like this, So which number is coming more frequently? This is number 4. Okay, we are repeating it. It has come there in the data 3 times. 7 is also repeated, but this is 2 times. So 4 is the mode of this distribution. That is the mode. Okay, that mode, like I will give you an example. If you are putting patients, you are doing one study, you have 100 patients, and out of them 40 10 in all you have comparing 3 studies. Okay, and in all samples 10 patients are coming to the ER with rupture of the membranes. Okay, so 10 10 10. Other people, they are coming like 2 patients, they have come with abdominal pain, one has come with vaginal bleeding. So what is the mode? Mode is the T-prom. Why? Because that value was being repeated 10 times like that. Okay? In a normal distribution, mean of the study, like you have taken the values, and the mean of the values will be equal to the median, and median will also be equal to the mode. So all mean, median, mode, they will be equal in a normal distribution. Then they will tell you that there is positively skewed data. Here the mean will be greater than median and median will be greater than mode. I will just show you that another picture also, just a moment please. So look at this one, like we were talking about normal distribution. Okay, in a normal distribution, mean is equal to median is equal to mode, like that is a normal distribution. Okay, look at this one, bell shaped curve. Okay, so here the mean, median and mode all are equal. Okay, then the data in the bell shape, it can show different types of representations, like it can be bimodal, it can be positively skewed, or it can be a negative skew. What is bimodal? It suggests two different populations. For example, metabolic polymorphism, such as some people, they will have fast metabolism, we will say they are fast, they have fast acetylation, so the metabolism of drug will be very fast. And some, on the other hand, we will have another group, like this one is the fast acetylator group and this one is the slow acetylator group. Here we will have to give less dose of the drug because it will be metabolized after a long period. Then in OB/GYN, I will give you example of cervical cancer and vulval cancer. So both types of cancers we will see in the women who are younger than 40 years of age. So here the high incidence. Then when they are in their 50s and 60s, this incidence will decrease, and then again this incidence will increase when they will be 70 years old. So you will say that vulval cancer, it has a bimodal distribution. So if they will give you a bimodal sample description, you will say that it has two peaks. So, and it has two different populations, like this is the younger group who have developed vulval cancer, and this is the older group who has developed complications. Now what is a positive skew? It is going towards right. Can you appreciate this one? It is saying the same, and these values are increasing towards the right side. Then you should remember that if I will show you this bell-shaped distribution, pay attention to this one, that the middle value neutral. If you will go towards right side, you will see this positive sign. Can you appreciate this one? This is positive sign. Okay, so when you will go to the left side, you will see negative values. So as the values will decrease when you will go towards the left side. So positive skew means mean, this is the mean is greater than median and median is greater than mode. So there is this here, the distribution of data is asymmetrical and the longer tail is on the right side. The both groups are not equal. Then negative skew means typically mean will be less than median and median will be less than mode. When it is going to the left, if you will see something like this, that it is extending to the left, you will see you will say that this is negatively skewed data. Going towards right means positive skew. Okay, so it's not that disturbing. When you will revise, you will know about this. Okay, so in the positive, everything be greater than the mean, and in negative, everything be less than the mean, and mean will be in the center. In the center. Then there is an other value which is called variance. This is a measure of how spread out a distribution is. However, like how much is the data scattered. However, all negative values that are lower than the mean, they will cancel out all the positive values that are greater. And to avoid this, the average squared deviation of each number from its mean is calculated. Because if you will write down this data, -1, +1, plus 2, -2, then as you know in the mathematics what happens if you have a number like this, so they both will cancel each other, right? So they will cancel each other. So to avoid this thing, what we do, we will write down all the values. Like there is a, we will see what is the difference between two values. Okay, like you have two values, you will see what is the difference between the first value and the second value. Okay, then you will see what is the difference between the second value and the third value. You will see there, you will take their difference, then you will make a square of them, and that's how you are going to add all the values. Like for example, in this sample, what you can do, here you have three numbers, 1, 2 and 3, and the mean is 2. So what is the variance? You will see 1 minus 2, we will take its square, plus 2 minus 2 square, plus 3 minus 2 and you will make a square, and then you will divide this value by 3. What you will get here? -2, 0, and here 1. So the variance will be -1 divided by 3. So that is the variance. Whatever value will come, it will be like it will be less than 0.33. Okay, so that will be the variance. Then you will see another value, it is called standard deviation. This is the square root of the variance. Square root, they call it jazar also. You will take the values and you will take the under root of this one, and then you will say that this is standard deviation. This is the most commonly used measure of spread. What I mean by spread is, here the values are in normal distribution, okay, and there will be like minimal gap like that, but sometimes this data will be widely spread, so it will not be similar, it will be going in each direction. So for that data you will have to use the values like variance and standard deviation. That's why for different types of studies we will use different types of data. So you should just have the basic concept that what are you going to do for them. You will see standard deviation. It means that how much it is different from the central value. Like if the standard deviation is low, it means that most of the people are falling in that standard, in that category. But if the standard deviation is very very different, then you will say that this is not so much reliable. Then you should know about standard error of a sample size. Z is the sample's standard deviation divided by the square root of the n. They will not go into the details, just remember that what is a standard deviation, and what if you see n, you will tell them that this is the size of the sample. Okay, and what is the standard error? You should know the definition. This is the definition of standard error. Standard error is the standard deviation of sample mean based on the population mean. You are taking the mean, you are not using one number. Okay, they will tell you that the mean value for this sample was this much. So if they are giving you mean of different studies, then you will say that they are asking you about standard error of the sample size. Then you will see another value very frequently if they are mentioning that in the in the studies, in the guidelines. This is confidence interval. So what is a confidence interval? If a series of samples are selected from a population and then mean of each is calculated, then 95% of the mean would be expected to fall within the range of two standard errors above or below the mean of this one, mean of these means. Like you have taken series of samples, they are selected from a population and then you are calculating mean. What was the mean? Mean was that you are taking the total values and dividing by the sum of all the values divided by the number of the values. That's how you are going to calculate the mean. And you have taken 10 samples from our population. Like you have taken samples for chorea amnionitis in cases of P-prone, and you have taken the 3 times you have taken the samples from the same population. So then you will see that every time when you will repeat the same study, the difference for the first group should be equal to the difference in the second group, or at least the values they will fall within range of the two standard errors above or below the mean of the means. So this common mean, it would be expected to lie very close to the population mean. So it will tell you that how much difference can be there. So 95%, you must have seen in the studies, they use the value 95% of the means. It means that you have a data like this one, like the same bell-shaped distribution. You have taken this data and you are taking the values. So when you have this type of data, you will see that this is one standard below the mean because the mean is in the center. This is two standard deviation where two standards below the mean, and this is 3 standards below the data. And this one is +3 means that it is more than one standard above this mean, and then 2 standards above, and then 3 standards. So if you will look at this one, so there is, if the value is -1 +1, then 68% of the data will fall under one standard deviation of the mean. Like it will be -1 or it will be -2. Then, so this is one standard, okay? Now look at this one. We are calculating from the middle. 95% of the data is falling here. One or two standard deviations below the mean. That will be 95% confidence interval. And if the values are 3 standards above or below, here you will go here, it will be above, and you will go here, it will be below the mean. So 99.7% values, they will lie 3 standards above the mean or 3 standards below the mean. Is it clear now? 68% values are ±1. Okay, so you will look at these pictures also, so it will be simple for you, inshallah. So we will go over it because this confidence interval, this is most commonly repeated measure in the guidelines in the studies, okay, because it will tell you that how much reliable the data is. So what is confidence interval? If a series of samples are selected from a population and mean of each calculated, then 95% of the values, they will lie within they would be expected to fall within the range of two standard errors above or below the mean of the means. This common mean would be expected to lie very close to the population mean. So in the bell we have the central value is the population mean. So the standard error of a means, it provides a statement of probability about the difference between the mean of the population and the mean of the sample. If they tell you mean +2, this is the standard error, and the mean -2, this is the standard error, it gives the range which has a 95% chance of including the population mean. So the confidence interval will be 95%. So for example, if you will get a score of the examination, okay, you will say that mean score is like people are taking those who are passing, their mean score is 80%. Okay, so what is the central value? This mean is 80%. Okay, then you will say those people who are getting 82, they are within two standard deviations, plus minus 2 within the mean. Now there is the other group whose score is 78. Then you will say that their score is 2 standard deviation from the mean. Is it clear now? Like the, yeah, 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 I will tell you. Yeah, 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 yes, yes. And if it is more than 2 standard deviations also, that is also reliable, and again 95%, okay, because it is, we are including both values, okay. Look at this one. We are including positive values and the negative values. Okay, we are including both values. So we can also divide. I think it's a simple concept. It will not be confusing you. So that's all. Like I will repeat here also. Confidence interval. This is the range of values within which the true mean of the population is expected to fall with a specific probability. So if the 95% confidence interval for a mean difference between two variables includes 0, then it is not significant difference. So if the confidence interval it includes a number 0, then it is not reliable, that one. If the 95% confidence interval for odds ratio or relative risk it includes 1, if it includes 1, then it means that data is meaningful. Just remember, this is the difference, okay? So if the confidence interval between two groups it doesn't overlap, then statistically significant difference exists. And if the confidence interval between two groups overlap, it means no statistical difference between the groups. So that's how you are going to define the studies, okay? They will not be so hard, they will ask you simple things, okay? So mean will fall plus minus 3 standard deviations between the confidence interval. And this fact is important, that if the confidence interval between two variables includes 0, then you will say there is no significant difference, there is no difference in the groups. And if the confidence interval includes 1, it means that this is there is a difference between the groups, okay. And if the data between this is good, okay. So if the confidence interval between two groups it doesn't overlap, so it means there are statistically significant difference when they are not overlapping, like they are not going, values are not shared. Then if the confidence interval between two groups overlaps, usually no significant difference exists because they are going to have common features, okay. But when it is not overlapping, not mixing up, then it means that the data is meaningful. Sometimes they can ask you about level of evidence for interpretation of the studies. So then they will ask you that what is the level of evidence for a certain study, because if the level of evidence is high, it means that the results are more reliable. So if it is 1 plus plus, it means that this is very highly reliable data. Like where do we see that highest level of the evidence? If we have meta-analysis. What is the meta-analysis? When you are combining, answering one question and you are getting results from many studies and you are combining them, that is a meta-analysis. Then systematic reviews of randomized controlled trials. Um, what is a systematic review? That you have, it was the review of the studies, and this is review of the randomized controlled trials, or randomized controlled trials with a very low risk of bias. Bias means that we are not bending towards one opinion. Like if you want to prove something, we will not say, like we want to say that patients with the cervical cancer, if they are 40 years old, they are going to live longer. So this is if we are judging it by study, then we will say that we have, and we are proving that it is going to, that the younger patient, they are going to live longer. Then we need to see that at what stage these patients were diagnosed and what was the stage of the disease at that time. If we don't correct the data for these things and we compare them with the people who were diagnosed, like let's say that people who were at 35 years of age, and they were diagnosed at a very early stage, and then we are comparing them with someone, another group, where the cancer, cervical cancer, was diagnosed in the third stage, and they were older people, like they were 70-year-old. So then this is a selection bias, because we are comparing a younger group who was diagnosed at an early stage, and then we are saying that they lived for a longer time. Okay, so this is also a bias, and we are comparing wrong populations. So highest level of evidence will come from meta-analysis, systematic reviews of RCTs, or randomized controlled trials with a very low risk of bias. So that is the highest level of evidence. Then 1 plus, yeah, meta-analysis, when you want to answer some question, and you will combine results of many studies. Okay, and then you will say that most, like 10 studies are favoring one point, then you will say that 10 studies, they favored this point. So we are also believing in that point, because that is very helpful. Okay, two things are always confusing students, that what is meta-analysis and what is a systematic review. So meta-analysis, this is a method of statistical analysis that pools summary data, like they have read 10 studies and they have summarized them, and they will say that they have collected information from multiple studies for a more precise estimate of the size of an effect, that if we will do a certain intervention, what benefit we are going to see. And it will also estimate the heterogeneity of the effect sizes between studies. Heterogeneity, that there were different groups, not similar group had similar questions. Okay, it improves strength of evidence and generalizability of the study finding. And but this is limited by quality of individual studies and bias in study selection. So where this is not going to cause any bias, the bias is coming from the studies, because maybe they were non-biased, they were not properly randomized. So that is, when you are taking results from different studies, you will say that this is a meta-analysis. Okay, then we can also say that this is a statistical technique for combining the findings from independent studies, and is often used to assess the clinical effectiveness of healthcare interventions. We will say that RCT shows that RCTs have shown that we should give antenatal corticosteroids at 26 weeks of gestation to get better results, better chances of survival. So we will say this is a meta-analysis. Why? Because most of the studies, they have favored this one. Meta-analysis, it combines data from two or more randomized controlled trials to provide a more precise estimate of the treatment effect, and giving due weight to the size of the different studies included. Okay, and the validity of a meta-analysis depends on the quality of the systematic review on which it is based. The aim should be to include all relevant studies. Look for the presence of heterogeneity. Okay, and then explore the robustness of the main findings. That how robust is the data, not one thing, it is going to cover many things. How robust, how strong is the data, how strongly it is supported. Okay, so then the main requirement for a useful meta-analysis is a well executed systematic reviews. If the review is unsystematic, then the meta-analysis may provide statistical estimate that is wrong. So the systematic review should be better, because meta-analysis depends upon systematic review. Now, what is a systematic review? It means a rigorous synthesis of all the literature on a specific question using methodology that reduces the influence of bias. Here, can you see the all the literature on a specific question? See, you will define one question, okay, and then you will go over all the literature on that question. Like I am telling you that you will take 10 studies and which are answering one question, and they are telling you that they reviewed the literature, and then there were like clearly formulated questions, like you are looking for something very specific, okay. Then you will use explicit methods to identify, select, and critically appraise relevant research. Like in your exam, they gave you abstract, okay? They asked you to analyze that. Then use all relevant studies, published and unpublished. Then it uses explicit methods to collect and analyze data from the studies that are included. Statistical methods like meta-analysis may or may not be used to analyze and summarize the results of included studies which are considered similar enough to combine. Systematic review methodology is central to meta-analysis. The objective of systematic review is to present a balanced and impartial summary of the existing research, enabling decisions on effectiveness to be based on all relevant studies of adequate quality. This means requirement of a systematic review is a complete, unbiased collection of all the original studies of acceptable quality that examine the same therapeutic question. Okay, they are based on, you are making one question and then you are trying to find answer, and there are many checklists for the assessment of quality of systematic reviews. For example, quorum statement, which means quality of reporting of meta analysis. So how do we do you get it now, that in cases when you are trying to do a systematic review, you are correcting? Yeah. Yes. 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 Yeah, regardless of the strong, yeah, that's very good, because they will ask you this question when they will ask you to assess a study. Then they will ask you which one is the highest level. So I will agree with you that this is the highest level, because systematic review can be it can depend, it will depend upon the quality of the studies. That those were good studies. A good study is the one where the bias is minimum, okay, and the things are more accurate and reliable, okay. We are not fiddling with the data, we are not manipulating the data, you are getting the actual data, okay. So you will find one question and then you will answer, try to read each and everything on that question. Like you want to see what is the chance of survival in a certain group, and you have taken all studies which are published and unpublished work, and then you will try to answer that question. So this is a systematic review. But when you will combine all studies and then you will take the best evidence for that question, then it will become a meta-analysis. That's why meta-analysis is at the highest level of the evidence. Here it is, okay, high quality meta-analysis. So that is clear. So now what is 1 plus? Well, well conducted meta-analysis, systematic reviews of RCTs or RCTs with a low risk of bias. Here was high quality, okay? Here well conducted. So a bit low than, a bit less reliable than 1 plus plus. Then minus 1. It means, and this is 1, okay? It means meta-analysis, systematic reviews of RCTs or RCTs but with a high risk of bias. They will not go into this much detail, but still 1 plus 2 and 1 plus and 1, they are still highly reliable. They will fall in that one. That is the highest level of evidence. Then 2 plus. High quality systematic reviews of case control or cohort studies, high quality case control or cohort studies with a very low risk of confounding bias or chance and a high probability that the relationship is causal. You don't have to go into detail, you just need to remember these first 3 points. Okay. +2 means well controlled, well conducted case control or cohort studies with a low risk of confounding bias or chance and a moderate probability that the relationship is causal. Then case control or cohort studies with a high risk of confounding bias or chance and a significant risk that the relationship is not causal. Causal means here it has just happened by chance, and here that it was uh, maybe it was intentional. Okay, so it may not be that much reliable. Then non-analytical studies, for example case reports and case series, because people are sporadically reporting them. Okay, they have not been researched. Then expert opinion and formal consensus. Then there are different levels of evidence for accuracy of a diagnostic test. So these are for the studies, and now if you have to tell about a test 1A, you don't have to go into this detail, just briefly. Systematic reviews with homogeneity of level 1 studies. Homogeneity means that there are minor or no variations in the directions and degrees of the results between individual studies that are included in the systematic review. Level 1 studies, they are the studies that use a blind comparison of a test with a validated reference to group, like which is called a gold standard. Or in a sample of the patients that reflects the population to whom the test would apply. Then what is 1B? It means level 1 studies. 2 means level 2 studies or systematic reviews of level 2 studies. And level 2 studies are the studies that have only one of the following, like if they either they will have a narrow population, which is the sample doesn't reflect the population to whom the test would be applied, or they use a poor reference standard, defined as a test where the test is included in the reference or where the testing affects the reference. Then third is the comparison between the test and reference standard is not blind. So the researcher or the patient, they knew that they are getting a test. Then there will be case control studies. So all in level 2. For level 3 studies or systematic reviews of level 3 studies. Level 3 studies are the studies that have at least 2 or 3 of the features of the level 2 studies. Then level 4, it means consensus, like they have read some reports and then they are giving their expert committee report or opinion and or clinical experience without explicit critical appraisal, or based on physiology or bench research or first principles. So basically you have to focus on the levels of the evidence for interpretation of the studies. Okay, for the test they will not ask you, but if you remember that this is a plus point, that 1A means that this is a good test. Okay, so that was all about meta-analysis and systematic review. So if you want to conduct meta-analysis, how you should proceed? Decide the question, then identifying suitable studies. Meta-analysis requires a comprehensive search strategy using several databases such as Medline, Embase, Cochrane, which is central register of the controlled trials, then hand searching of key journals and checking of the reference list of the papers is also recommended. Like you must have seen in these published studies, then you are going to see like maybe 100, maybe 50 references. So you have to see that the references are also good. By good I mean that they have been properly researched without any bias. The key term used to search the database, which is also called search strategy, it needs to be developed carefully. And the strategy should include papers with specified terms. Then they should exclude paper that do not meet certain criteria. They should only include studies that follow certain research designs. For example, randomized controlled trials. Then how do we assess the quality? We need to decide which studies are sufficiently well conducted to be worth including. So this process may introduce bias, so there need to be explicit and objective criteria for inclusion or exclusion of studies on quality grounds. There are several scales for assessing the quality of the individual clinical trials. Once a quality score it has been assigned, the impact of excluding low quality studies should be assessed by sensitivity analysis. Then you should calculate, then in the end they should be, when they are conducting the clinical RCT beta analysis, then they should calculate the effect sizes. So the results of individual trials are summarized as a ratio of the frequency of the events in the intervention group to that in the control group. So you are, because you want to see the difference. So how you will see the difference? You will see the difference in the control group where you know about the conditions, and then in the experimental group or the intervention group. That's how you can see the difference of made by any intervention. Like you are giving this steroids, and then you will see that in which group you have given steroids. So did the incidence of respiratory distress drop or it remained the same? Okay. So you are going to see the difference between two groups. And this is presented as either the odds ratio or the risk ratio. Risk ratio is also called relative risk. So although technically different, the odds ratio and the relative risk, they are usually interpreted in the same way. We use them for different types of studies. We will just talk about them. So the findings from individual studies are then combined using an appropriate statistical method, with the estimate from each study is weighted by the precision of the estimate. What is the precision? That every time you will do that, and they will fall within a central value. They will not be exactly the same. If they will be exactly the same, then we will say that they are accurate. But if they will fall around a central mean, then you will say that the results are precise. Okay. So after calculating the size of effect, you will check for the publication bias. A key step in meta-analysis is checking for publication bias, as studies that obtain negative findings, they are less likely to be published than those that have positive findings. Because negative findings means they are also important, that you are excluding something. But if you get the positive results, then you will see that because the positive results, they will tell you that intervention is going to be helpful, so then you will like to expand on those options. So one way of assessing the presence of publication bias is using a funnel plot. Funnel plot, it displays that the studies included in the meta-analysis in a plot of effect size against the sample size, or another measure of the extent to which the findings could be affected by chance. They will not go into such details, but you should just have some idea, so you can ignore this thing. Okay. Smaller studies, they have more chance variability than larger studies, so the expected picture is one of a symmetrical inverted funnel. An asymmetric plot suggests that the meta-analysis may have missed some trials. Asymmetry, it may also occur because smaller studies, they tend to have larger effect. So that is the point. Then you can leave this one, this funnel plot. Briefly we will go over this one. So a funnel plot means the vertical axis is some measure of the precision of the estimate of the treatment effect. Just you should just understand the basic principle, that if the confidence interval is small or larger the sample size. Small difference means that the sample size is larger, so the more precise the study. The smaller the confidence interval, the more precise the study, and the further up the study is placed. So that is more reliable. Suitable measures of precision, they include standard error of the log of the relative risk and sample size. The horizontal axis measures the treatment effect. So For example, the relative risk presented on a log scale. So the point estimate for each study is then plotted, and a vertical line may be added to indicate the pooled estimate from the meta-analysis. Less precise studies with smaller sample size, they are more affected by the chance that there can be some role for the chance, and so they are more widely scattered about the pooled estimate. Larger studies will be expected to be closer to the pooled estimate. This should produce a triangular shape or inverted funnel shape. So just remember, this is important for you, this information. They will ask you that how good or bad a study is, and then you will tell them that if there is a smaller confidence interval means the more precise the study, and the further up the study is placed, like the evidence from this study will be good. So I want you to remember just these two lines out of this full paragraph. Then what is sensitivity analysis? Inclusion exclusion of different studies may affect the main findings of the meta-analysis. Sensitivity analysis is used to determine how the results of the meta-analysis they are changed by varying the approach to aggregation of studies. For example, what happens if unpublished studies are excluded? So how do we present the findings? We can use forest plot. Have you ever seen a forest plot? In many studies you are going to see this. Okay, so forest plot is also important. So data from the funnel shape. Okay, so but you should just remember that funnel shape, and it should all the data funnel me you have seen the funnel, right? All the data should come in a triangle. Okay, I will I will give you some pictures also. Okay, all the data should come in the shape of a funnel, like I will show you if I can find some here. No, it's not here. So I will show you its pictures also, don't worry about that. But forest plot you have seen. Okay, this is a forest plot. Okay, so you can see again there is a zero, values are increasing and the values are decreasing. So data from meta-analysis, they are presented in a forest plot. This shows the results from every individual studies as blobs or squares plus a horizontal line representing the confidence interval. These horizontal lines are showing the confidence intervals. So the size of the blob or square is proportional to the precision of or sample size of the study. The aggregate effect size obtained by combining all the studies, and it is displayed as a diamond. Diamond is the sum of the studies. Okay, diamond shape. Here it is. The aggregate effect size obtained by combining all the studies is displayed as a diamond. This is the mean of all studies. So where difference between means are presented, null means no difference. Null has a value of 0 and x scales are normal. Where ratios are presented like odds ratio, null has a value of 1 and the scales are logarithmic. So actually what happens here is they are telling you that these are the confidence intervals. Okay, then they will mention all variables. What are the groups? Are they heterogenic or they are not? Okay, and then here will be the results of the findings. Usually for a plot it will tell you that how many different groups were there, what was done and what was the result. If any study, any confidence interval crosses this middle line, it means that they are not significant. Okay, so let's see what is heterogeneity. Yeah, yeah, circle is the, yeah, yeah, they are different. Okay, this size, the circle or the blob, it is telling you the precision of the sample or the samples or the sample size of the study. What is precision? I can show you like this. These are basic concepts like Precision means that when you are analyzing the results, they are falling closer to a certain given value. Okay, like they are not very much scattered around that one. Yeah. You are doing a test, okay? Precision, what is precision and accuracy, okay? This is precision, okay? Like by if we will define that one, precision means reliability. Reliability, okay? The consistency and reproducibility of our test and the absence of random variation in a test. So random error, yeah, yeah, you will get the same results, but you know you are getting the same results. This is high precision because they are falling towards the expected value, okay? We had a mean and the values are lying near that one, so this is highly precise test, okay? Now there is another test. You are getting the results again. They are precise, but they are falling toward going towards the periphery. They are away from the central value, so it will have a low precision. And why this precision is important for us? So random errors, which are like they are not consistent. They are just occurring randomly. Anywhere there can be this error. Random errors, they will decrease precision in a test. If there is high precision, there will be decreased standard deviation. So the test will be highly precise test, so that will be more reliable because precision means reliability. If there is high precision, it means statistical power is also higher. Okay, so if the test is positive or negative, it is going to be more accurate, more reliable. What is accuracy? This is precision, okay? And what is accuracy? Accuracy means, as you know, that precision and accuracy, we are usually using them to describe that this level of the test, that how much useful or useless a test is. So the trueness of the test measurements, that how accurate is the test, how true is the test, and the absence of systemic error or bias in a test. So look at this one. Whenever you are doing this test, the results are positive or negative, they are giving you the accurate results, so the results are valid. So here if you will see, like the test results are here, like they are scattered, you will say that this is highly accurate test because it is diagnosing those with a high chance of being sick, then those who are at the borderline, and then even in the groups where the chances of positivity of the test are low, still it is detecting them. So this is highly accurate test. But if you will think in terms of precision, this is low precision, okay? Now this test, it is diagnosing just one, the value is near the expected value, okay? And all other values are far and away from the expected value. So the accuracy is low. It's not accurate, okay? And precision is also low. Why precision is also low? Like this whole area you have sampled and one is positive here, one here, one there, okay? So they are scattered around the expected value. So you're not going to reproduce the same test. Near it will not be near that expected central value. Highly precise when all findings are near the expected value. Okay, and this one also, it is still falling here, but what is the precision? Precision is still high. Why? Because we will say that the chance of having this finding is low, but still in that group it is positive. You are seeing the cluster, so you will say that this is highly precise for a low group where the chances of finding something were low. Here the accuracy is high. Why? Because all the results are coming near the expected value, right? So here the accuracy is low because the test results are away from the central value. Is it clear now? And the benefit is that if the results are highly precise, it means less standard deviation. And high precision also means high statistical power. And the systematic error is low, then if there are systematic error, then they will decrease the accuracy in the test. So basically they will ask you about different types of studies, how do you interpret them. So we were talking about the forest test, and we said that data from the meta-analysis are presented in a forest plot, and it shows the results from every individual study as a blob or square plus a horizontal line representing the confidence interval. And lower the confidence interval, the more reliable the finding. So the size of the blob or square is proportional to the precision or sample size of the study. The aggregate effect size obtained by combining all the studies is displayed as a diamond, that is the sum of the studies. So where difference between means are present, null hypothesis, which means that there is no difference between the samples. So the null has a value of 0. So, and the x scales are normal. Where ratios are presented, for example, odds ratio, null, it will have a value of 1 and the scales are logarithmic. So what is heterogeneity? A major concern about meta-analysis is the extent to which they aggregate studies that are different in kinds. So different types of studies, they will be heterogenic. And to get a precise answer to a specific question, only studies that exactly address the question they should be included. However, studies are rarely identical in design or execution, and these differences they can influence the amount of the treatment benefit or the size of the effect. So it will show cause heterogeneity. Meta-analysis should test for heterogeneity using tests like Cochrane's Q test, or the I2 statistics, which scores heterogeneity between 0% and 100%. So 25% will be low heterogeneity, 50% will be moderate, and the 75% will be high heterogeneity. So when there is a high heterogeneity, it may be inappropriate to perform a meta-analysis. So if there is low heterogeneity, then again it is not a good trial. Okay, so usually they will try to go up to 50%. So in the exam they will show you this one, then you will say that this is the center line, here they will display the groups, here will be the effects. So you will say, they will ask you what is the net result, you will say where is the diamond, then you will say this is the net effect or the major sum of the aggregate of the size of the effect. And these are confidence intervals, okay. And if you will see small squares, or you will see like small, and they can show you blobs also like this, they will tell you about the sample size, but usually they will put the square. So these studies which are going here, they are giving you some results, but basically we are concerned here, everything mentioned on the left side is more reliable, okay. And then you will see if the confidence interval is not crossing, it is staying here, it means that that study is meaningful. Why? Because they will have a value of 0, and it means, you know, this 0 is in the center. So the difference between means are presented, and the null has a value of 0, and the x scales are normal. So that is the point. So sample should be heterogenic, but your heterogeneity should not be more than 75%. Okay. So let's go back to this normal distribution, because the data can be distributed normally or data can be distributed abnormally. There are different ways, okay. So let's see what is this. This is family of distributions with the same general shape, symmetrical and bell shape. And the distribution is defined by two parameters, the mean and the standard deviation. If these are known, then one knows essentially as much as if one had access to all the data. So if you know the mean and you know the standard deviation, it means that you have interpreted the full study. So in the normal distribution, mean is equal to median is equal to mode, and the data are unimodal. Unimodal, they have one highest value. We have just we just revised that one also. This is the normal distribution. Okay, so just one peak is there and the all data is scattered around that one. So data are unimodal, they have one highest value and the area under the curve is considered 1. 68% of the data fall within one standard deviation of the mean, 34% will be above the mean and 34% will be below the mean. We have just seen that one. Okay. Then 95% of the data they fall within within two standard deviation of the mean. It is actually 1.96, but to take a whole number we will say that this is within two standard deviation of the mean. 99.7% of the data will fall within three standard deviations of the mean. And the standard normal distribution, it has a mean of 0 and standard deviation of 1. This is taken as the standard. Then there are tests for normality. Like visual inspection of the frequency of distribution, we can use histogram. It will tell us the number of peaks and symmetry. And we can use statistical packages for the value of a skew. A distribution is skewed in if one of its tails is longer than the other. And kurtosis, which means the degree of peakness of the distribution. The kurtosis value for a normal distribution is 0. Negative values and observations, they cluster more closely to the center, and positive values, the observation is that cluster will be less close to the center. So which tests? Kolmogorov and Smirnov test and the principal goodness of fit test for normal and uniform data sets. Then Shapiro-Wilk test, it means that it is reliable when the size of the sample is less than 50. So Shapiro-Wilk test you are using when the sample size is less than 50. And if it is more than 50, then you can use this Kolmogorov-Smirnov test. Then they will not ask you about these tests. They will ask you about positive skews, what is a normal distribution, and what do you understand by 1 ST, 2 ST, and how many values lie there, and what type of review is this one, if they will give you a meta-analysis or something, so you should be able to differentiate between them. So if they will tell you that that the doctor has reviewed many systematic reviews to answer this question, then you automatically you will know that this is a meta-analysis. Then there are limitations of the normality test. Small samples almost always pass a normality test. So the smaller samples we are using. With large samples, minor deviations from normality, they may be statistically significant. However, such small deviations, they will not affect the results of most statistical tests. Decisions on which statistical test to use, it should not be based on a normality test of one data set. Then parametric and non-parametric tests. So we talked about what are the tests of normalities. Like positive, we will say positively skewed or negatively skewed data, and then we can use these two tests. Then parametric and non-parametric tests. What are parametric tests? There are certain assumptions that data are interval or ratio. Then normally distributed data, skew and kurtosis, they are between -1 and +1. Variance is equal between groups. Variance can be up to 4 times different from each other, but no more than that. So this assumption only applies to independent design. Examples include independent t-test, paired or repeated measure t-test, then ANOVA with Poisson tests to compare group means. Then there are non-parametric tests. So you should only know that which are the parametric tests and which are non-parametric tests. Non-parametric tests, they do not require parametric assumptions because interval data are converted to rank ordered data. All tests involving rank data, like data that can be put in order, they are non-parametric. So we can do different tests, like we can do this Mann-Whitney U test. This is one of the most powerful Non-parametric test for comparing two populations. It is used to test the null hypothesis that two populations they have identical distribution function against the alternative hypothesis that the two distributions their functions differ only with respect to the location, like median. Just remember Mann-Whitney-U test, non-parametric test when you have two populations. Then Kruskal-Wallis test, non-parametric test used to compare three or more samples. Then Wilcoxon-Signed rank test. This is designed to test a hypothesis about location. Location is the median of a population distribution. We read about median that half values will be above that value and half values will be below that value. So if one involves the use of matched pairs, for example before and after data, in which case it's a test for a median difference of 0. If they are giving you before and after and the data are they're not comparing in the same group, then you will say that you will use Wilcoxon signed ranks test, like they're telling you before and after data. Then chi-square test, when you are comparing three groups. Then what is a p-value? P-value means this is the statistical data are typically accompanied by a p-value, which is the mathematical probability that the data are the result of random chance. Then any finding which has occurred, if there is difference, this is because of the random chance. Data with low p-value, which means less than or equal to 0.05, they are said to be statistically significant. A probability value of less than 0.05 means that there is a 1 in 20 chance that the data is the result of random chance. So we have done study and the data is reliable and things have very little chance that the things have happened by chance. P-value of 1, it means that there is a 100% certainty that any association or difference occurred purely by chance. Then there are type of errors, like they can be type 1 error or type 2 error. Type 1 error means incorrectly rejecting a true statistically null hypothesis. The experimental hypothesis is supported by the data when it is in fact false. Okay. So what is the null hypothesis? When you are going to describe results in a study, you will have, there is a way of doing statistical analysis, and there are ways to present the data. So whenever we want to prove something, we want to do some study, we will have to make some assumptions, like you are supposing that these things are happening. If they are not happening, then if you have no starting point, you cannot say that what exactly you are going to search. So why do we use this? Scientific method starts when you will suppose something. Okay, you will suppose something, then you will collect data, and then you will analyze that data, that these things are happening and they are existing or they are not. Okay, so the scientific process, it starts with some suppositions, some assumptions. So after that we will collect the facts, then we will analyze them, and then we will reach some conclusion or inference. Okay, so that's how a scientific method is, and that is the scientific way of doing things. So there are two types of statistical hypothesis when you are only supposing things. Null hypothesis, which is represented as H0, or alternative hypothesis, which is represented as H1. What is null hypothesis? Hypothesis of no difference or relationship, like it means no relationship. For example, there is no association between the disease and the risk factors in the population. This is null hypothesis. Hypothesis of no difference or no relationship. Then alternative hypothesis, which is H1. It means that there is some difference or relationship. This is the simplest way to put them, okay, to explain them. For example, there is some association between the disease and the risk factor in the population, while null hypothesis said no difference. Alternative hypothesis says that there is some difference. So how do we put the results? What are the outcomes of statistical hypothesis setting? What are correct results? Stating that there is an effect or difference when one exists. Null hypothesis rejected in favor of alternative hypothesis, because we assume that there is no difference or no relationship between the groups. But then we did the study and we found that there is an effect or there is a difference between the groups. So null hypothesis is rejected, that they, because null hypothesis says no difference. So we will accept alternative hypothesis that there is a difference between the risk factor and disease. Then stating that there is no effect or difference when none exists. So these are the correct results. So it will mean that null hypothesis not rejected, because null hypothesis says that there is no effect or no relationship. So the same thing has been proven. So we will accept null hypothesis. It will not be rejected. So then we can make certain errors. We call them type 1 and type 2 errors. Type 1 error, it states that there is an effect or difference when none exists. That there was no difference between the groups, but we did study and we found that there is some difference. So we are rejecting null hypothesis. We will make type 1 error when we will reject null hypothesis. So it means type 1 error means you are stating that there is an effect or difference when none exists. The groups were not different, so we should have accepted null hypothesis, but we made a mistake. We rejected null hypothesis incorrectly. And we said that there is an effect, and there is an effect and there is some difference, but in fact there was no difference, there was no effect. So by mistake we rejected null hypothesis, incorrectly rejected in favor of alternative hypothesis. We represent it by alpha, and alpha is the probability of making a type 1 error, and P is judged against a preset alpha level of significance. Usually this will be set at 0.05. If probability is less than 0.05, then there is a less than a 5% chance that the data will show something that is not really there. So the chance of having something by chance will decrease. So this is also known as false positive error. Type 1 error or false positive error are the same thing. Alpha is when you accused an innocent man. You can never prove the alternative hypothesis, but you can reject the null hypothesis as being very unlikely. So type 1 error, rejecting null hypothesis incorrectly in favor of alternative hypothesis, that is type 1 error. What is type 2 error? Stating that there is not an effect or difference when one exists. So null hypothesis is not rejected when it is in fact false. So failure to reject null hypothesis when it was wrong, this is called type 2 error or beta error. Beta is the probability of making a type 2 error. Beta is related to statistical power. Power is equal to 1 minus beta, which is the probability of rejecting null hypothesis when it is false. So increased power, if the power is increased, then beta chance of having type 2 error will decrease. Why? Because there will be a bigger sample size, and then with a bigger sample size, so expected effect size will also increase, and precision of measurement will also increase. So type 2 error, this is also known as false negative error. So beta means that you blindly let the guilty man go free, that he should have been rejected, he should have gone to jail, but nothing happened. So type 2 error, failure to reject null hypothesis when it was wrong. That is the error. So again I will repeat for you because you are going to see these things. Type 1 error, incorrectly rejecting a true statistical null hypothesis. The experimental hypothesis is supported by the data when it is in fact false. Type 2 error, incorrectly accepting a null hypothesis when it is in fact false. For example, in a clinical trial of a new drug, the null hypothesis might be that the new drug is no better on average than the current drug. A type 2 error would occur if it were concluded that the two drugs they produce the same effect when in fact they produced different results. So these are type 1 and type 2 error. These are type 1 and type 2 error, represented by alpha type 1 error and beta type 2 error. Then we use other things like risks and odds. So what is an attributable risk? Disease rate in exposed person minus the disease rate in unexposed group. So you will say that how much risk has increased after exposure to the risk factor. Then what is relative risk? This is the ratio of the rate of disease in exposed group to the rate in the unexposed group. That is relative risk. Then what is attributable risk? This is the rate of disease in unexposed person. So it will be taken as relative risk minus 1. So how we can explain this relative risk and the relative risk and attributable risk. So any idea about that? Yes, in the risk, yes. Yeah, yeah, that's excellent. So if we want to quantify the risk, then we can use this 2 by 2, this table. And this is also called contingency table or 2 by 2 table. Okay. Here the results of the test or here the disease. If the test is positive and the disease is positive, and sometimes the test is positive but the disease is negative. Sometimes the test will be negative and patient will have disease. Okay. Because maybe the disease has just started and we don't have enough this accurate test or very sensitive test to diagnose that, so the disease is still the test is negative but disease is present. Then test can be negative and the patient will not have disease also. So this is called contingency table. Then if you want to quantify the risk, we can use odds ratio. So odds ratio, this is typically used in case controlled studies, and OR designated as OR, and it means the odds of a certain exposure given an event. For example, disease versus the odds of exposure. It means in the absence of that event. So no disease. So how do we calculate it? In the exposed and in the unexposed groups, there is a way of calculating that, but in the exam they will not ask you to calculate, they will just ask you the definition and in which type of studies you are using them. So you are using odds ratio in case control studies. Then what is relative risk? This is typically used in cohort studies. Risk of developing disease in the exposed group divided by the risk in the unexposed group. Risk in the exposed group divided by the risk in the unexposed groups. For example, If 5 people out of 10 they were exposed to radiation and they get cancer, and 1 in 10 people they're not exposed to radiation, they get cancer, then the relative risk is 5. It means indicating a 5 times greater risk of cancer in the exposed groups than the unexposed. And usually it is done for the rare disease. Rare disease means that the prevalence is low. And odds ratio, it is approximately the same as the relative risk. If the relative risk is 1, it means no association between exposure and disease. If relative risk is more than 1, it means exposure is associated with increased disease occurrence. So more than one value of the relative risk that the patient has, there is association between the exposure and the disease. Then another value is attributable risk. This is the difference in the risk between exposed and the unexposed group. For example, if risk of lung cancer in smokers is 21% and the risk in the non-smokers is 1%, so what will be the attributable risk? It will be 21 minus 1, so the risk will be 20%. So attributable risk, difference between the exposed and the unexposed group. And here we are taking the ratio, that how many were exposed and how many were unexposed, so how many did get the cancer. So it will be, the attributable risk will be in percent. So you should remember these two values. Here we are dividing them and taking out the relative risk, but here we are just subtracting them, the difference in the exposed and the unexposed. Then what is relative risk reduction? The proportion of risk reductions attributable to the interventions as compared to a control. Control is the one where we didn't offer any intervention. So if there is 2% of the patients who receive a flu shot and they develop flu, while 8% of the patients who didn't receive vaccination and they develop flu, then what is the relative risk reduction? 2 divided by 8, so the answer is 0.25. So, and the relative risk reduction is equal to 0.75 or 75%. So we can say that if you will give flu shot to 100 people in the population, 75% they will have relative risk reduction, so they will be less likely to develop flu. Okay, and while if you will give, so that's how you are going to interpret them. Like 2% who received vaccination, they developed flu, and 8% who didn't receive vaccination, they developed. So what is the relative risk? That relative risk will be 75.75. So if you have relative risk will be 0.25, and what will be the risk reduction after taking vaccination? 0.75. So you will say that if 100 patients they will get vaccination, 75% they will not get flu, and only 1 in 4 they are going to get the flu. That's how you will interpret the results of study. Then what is an absolute risk reduction? The difference in risk, not the proportion. So here, these were the proportions, but here the difference in risk attributable to intervention as compared to a control group. For example, if 8% of the people who receive a placebo and placebo vaccine, they develop the flu versus 2% of the people who receive a vaccination. So here again the same group, 8 minus 2, so 6%. So absolute risk reduction was 0.06. That is the thing. Okay. So they will basically ask you about the relative risk and the attributable risk, and then attributable risk, the rate of disease in unexposed person. So relative risk minus 1, this will be attributable risk. Then odds. Odds ratio, this is a ratio of the probability that an event will occur versus the probability that the event will not occur. So probability of an incident to occur, an event, divided by 1 minus the probability, the chance that this event will not occur. The probability of pulling a jack of heart is in, like, there are 52 cards, so the chance that you will get a jack, the probability jack of hearts, the probability is 1 by 52, whereas the odds of pulling the jack of hearts is 1 by 51. For example, if you draw cards and have 3 spades and 1 diamond, then the odds of drawing a diamond are equal to 1 by 4 and 3 by 4. They will not ask you to calculate it. So the odds are going to be just 0.33. This differs from the risk of odd probability. The risk of drawing the diamonds is equal to number of diamonds divided by the total number of the cards drawn. So you have taken out 4 cards, so you will divide 1 by 4, so you are going to get 0.4. You should just focus on the definitions. And then, what is odds ratio? The ratio of odds. The ratio of the odds of an event occurring in the exposed group versus in the unexposed group. Most randomized controlled trials, they express results as risk ratios. Case-controlled studies where the data are obtained retrospectively and meta-analysis, they typically report results as odds ratio, where in case-controlled studies and meta-analysis, just remember that if they are giving you an odds ratio, then you will say that this is either a meta-analysis or this is a case-controlled study. So when the primary outcome is rare, relative risk and odds ratio, they are equal. Odds ratio and relative risk, they are presented with 95% confidence interval. For instance, relative risk. So usually you must have seen that in studies, you must have seen in the green top guidelines also, they are giving relative risk is 2.5 and 95% confidence interval is between 0.6 to 4.5. So when the 95% confidence interval of the odds ratio or relative risk includes 1 as above, then the groups are not statistically significantly different. So 1 means that the groups, they don't have any significant differences. But yes, that is the point. Yes, that's how you express them. So what is a statistical power? The probability of rejecting a false null hypothesis, it is the likelihood that a study will detect an effect when there is an effect to be detected, that it will be correct. If statistical power is high, then the probability of concluding that there is no effect when there is one goes down. 80% power in a clinical trial means that the study has a 80% chance of ending up with a p-value of less than minus 0.05 in a statistical test. For example, so it means a statistically significant effect, if there really was an effect. By conversion, 80% is an acceptable level of power. Research is typically designed to test two hypotheses, the null hypothesis against an alternative research hypothesis, like we mentioned before. So research efforts, they may be wasted if studies, they do not have sufficient power to detect the effect of the interest. So how we can improve this power? By increasing the sample size. A study could reject or fail to reject the null hypothesis, and this decision can be correct or incorrect. There are therefore 4 possible outcomes. 2 are good outcomes and 2 involve errors. So correctly reject the null hypothesis when it is false. So what is the null hypothesis? That there is no difference or no relationship between the groups. Incorrectly reject the null hypothesis when it is true. Then correctly fail to reject the null hypothesis when it is true. Incorrectly fail to reject the null hypothesis when it is false. So types of error. If the research hypothesis is correct, then the null hypothesis will be false. So the researcher will want to reject the null hypothesis. If the research hypothesis is incorrect, the null will be true. the researcher will want to fail to reject or accept the null hypothesis. Incorrectly rejecting the null hypothesis is known as type 1 error. That is, finding a statistically significant difference when one doesn't exist. Type 1 error is the alpha level in the hypothesis test, and the level of error of the researcher is willing to accept. Incorrectly accepting the null hypothesis when it is false is known as type 2 or beta error. That is also called failing to reject null hypothesis when it is false. So it means that the finding no statistically significant difference when actually there is difference between the groups. So there are two ways hypothesis test decision, either we can reject them or accept them. So null hypothesis means that there is no difference between the group. So when it is false, it can be false or it can be true. So in the type 1 error, you are failing to reject when actually you are rejecting it when it was correct. And in type 2 error or the beta error, you have rejected the you have failed to reject null hypothesis when it was wrong. So the correct thing would have been 1 minus a. So to assess that's how you are going to interpret the results. So what is this 1 minus alpha? This is the confidence level, for example, minus 0.95. The odds of saying that there is no relationship or the difference gain when in fact there is none. So the odds of correctly not confirming our theory. So it means it is 0.95. It means that 95 times out of 100 when there is no effect, we will say that there is no effect. Okay, that will be 0.95. Then beta or the type 2 error, for example 0.2. So what is the meaning of this one? The odds of saying that there is no relationship or difference gain when in fact there is one difference. Okay, so the odds of not confirming our theory when it is true. So 0.2 means 20 times out of 100 when there is an effect, we will say that there is no effect. So basically we are failing to reject null hypothesis when it is wrong. So 0.2 here means that 20 times out of 100 we will make this mistake when there is an effect, and we will say that there is no effect. Then alpha type 1 error, it means that what is the significance level. For example, this is 0.05. So the odds of saying that there is a relationship or difference gain when in fact there is none. There is no relationship, there is no difference, and there is no gain, but we will say that there is one. And these are the odds of confirming the theory incorrectly. Okay? There is a chance that we will confirm the theory incorrectly. So 5 times out of 100 when there is no effect, we will say that there is one effect. So the probability of giving the wrong result is very low, which is 0.05%. So 1 minus beta or the power of study, for example, if they tell you that the power of the study is 0.8, what is the meaning of this one? The odds of saying that there is a relationship difference gain when in fact there is one. So this is correct. The odds of confirming our theory correctly. So it means 0.8 means 80 times out of 100 when there is an effect, we will say that there is an effect. So power should be as large as possible. Studies are designed to reject the null hypothesis rather than test whether the research hypothesis is true. This is because it is easier to prove an idea to be false than it is to prove an idea to be true. Key statistical decision in rejecting or failure to reject the null hypothesis rather than accepting or rejecting the research hypothesis. So how we can give an example? Like a randomized controlled trial. So this is null hypothesis, this is alternative hypothesis. Okay, here reject null hypothesis if the study is going in this direction, and then if it is going on right side, this is type 1 mistake when you are failing to reject null hypothesis when it is true. So a randomized trial is is being designed to test the hypothesis that a new drug X used for management of a third stage of labor will reduce blood loss at delivery. Then the null hypothesis states that the drug X didn't reduce blood loss at delivery. To test the hypothesis, we design a study to measure blood loss at delivery in women treated with drug X and compare it to the untreated women. We also set the level of error we will accept, like the alpha level. So the distribution in red, this is the sampling distribution we could obtain if null hypothesis was true, that there is no difference. Okay, if null hypothesis is true, you are going to get this one, and alpha is the expected chance of error, chance of something which is not confirming our assumption. So if we reject null hypothesis, find a significant difference when one doesn't exist, we would have made a type 1 error, which is represented by alpha. If we fail to reject the null hypothesis, then we would have made the correct decision, which is represented by the solid red portion, and this is labeled as 1 minus alpha. So the distribution in blue is the sampling distribution we would obtain if the null hypothesis were false. So this shows the value of the sample means we would expect if the drug X reduced blood loss at delivery. So this many people, they should show the difference, then we will say that this drug is good, it is working. If we fail to reject the null hypothesis, like our sample mean was not extreme, then we would have made a type 2 error, which means failing to reject the null hypothesis when it is false. This is represented by a blue striped portion. So this is type 2 error, this is type 1 error. So this is represented by the blue striped portion of the sampling distribution. If we had a sample mean that fell in the region marked by the solid red line, this is the solid red line is the rejection region. So then we would have made the correct decision to reject the null hypothesis. Correctly rejecting a false hypothesis is represented by the solid blue portion. One more is. So how the statistical power is affected? It is affected by the following, they will influence the statistical power: alpha level, sample size, effect size, and one-tailed versus two-tailed test. So we can see that our power graph, that there is a direct relationship between type 1 error, type 2 error, and statistical power. So when we increase alpha, we decrease beta, and we increase our statistical power. So sample size also has a direct effect on statistical power. When we increase the sample size, the sampling distribution of the mean becomes more leptokurtic, which means slender or thin, as opposed to the flat or platykurtic. This probably applies to all sampling distribution. Larger samples, they give a more accurate estimate of the population parameter. Therefore, the standard error decreases. So, how we can maximize statistical power? We always want to have enough statistical power in our studies to have a reasonable chance of finding the effect of interest. To increase statistical power, we can increase sample size, we can increase alpha level, we can use one-tailed test if appropriate, and we can select reliable measures for the study, and we can develop a strong research design. So use all information available to identify an appropriate population and recruit participants for the study. So higher or lower, like they will be going to one side, one-tailed test, like they will be going, like there are chances that this test is going to be positive. Okay, then you're going to find a relationship, or you already, if it is appropriate, sometimes you will have to, the tail is not necessarily towards the right side. If you think that things will be positive, like there will be relationship between the groups and between the exposure and the risk factors, you will be going towards the right side or the positive side. And if you think that the results they will not be going in the same direction, then it can be on the left side also. So you will have basically they will they will not go into that much detail. They will just ask you that how you can improve the statistical power. So your simple answer is increase the sample size and select reliable measure for the study, and then develop a strong research design and use all information available to identify an appropriate population. So it should be correctly representing the group where you want to conduct the study. Okay, so go. I know that this one is quite complicated, but I would encourage you that try to read it 1 or 2 times and listen to this video also, this tutorial, and then we will discuss. If you will have any concerns, I would like to explain them in the next meeting also. So if you have higher and lower alpha and beta, the lower the alpha, the lower the power, and the higher the alpha, the higher the power. So the lower the alpha, it is less likely it is that you will make a type 1 error. Type 1 error, so you will, it means that incorrectly rejecting the null hypothesis. So type 1 error means reject the null hypothesis when it is true. So the lower the alpha, it means the more rigorous the test. An alpha of 0.01 means the researcher is only willing to risk being wrong in 100 times in rejecting the null when it is true, or saying there is an effect when there really is not. An alpha of 0.01 means that you have a 99% chance of saying there is no difference when there is, in fact, there is no difference. So then increasing alpha increases the chances of making a type 1 error, saying that there is a difference when there is not. So it decreases the chances of making a type 2 error. Type 2 error means saying that there is no difference when actually there is difference between the groups, and decreases the rigors of the test. Increasing alpha increases power because one will be rejecting the null more often, accepting the alternative, and consequently, when alternative is true, there is a greater chance of accepting it. So the power will increase. Then we come to your question, type of studies. Type of study is very important because like before, they will show you they will give you an abstract. In each exam they will bring, okay, in each OSCE they will bring one. So you should remember that there are different types of studies, and you can identify by their samples, and you can also, if you become confused at that time, then you can you can see that on the basis of p-values, that they have given p-values, they have given you odds ratios or what. Then what is types of studies? They can be, yeah. Mm-hmm. In your exam, yeah. Mm-hmm. Mm-hmm. And yeah, yeah. So I will tell you that you can identify. Don't worry, okay? We will practice with that also. Observational studies. Sampling the target population and simply observing which risk factors are present in each subject. Then studies can be prospective. Like samples, they consist of subjects who possess or do not possess the risk factors, and the occurrence of the primary outcome is observed. You are going in the future, okay? Like they will have risk factors, and then you will see that with the risk factors, are they developing disease in future or not? Like the people are smokers, so you will see later that how many of them they develop lung cancer or heart disease. Then they can be retrospective. You are going backwards. Samples consist of subjects who have exhibited the primary outcome, like they were the cases, and have not exhibited the primary outcome, which are called the controls. And the investigator looks backwards to identify the risk factors in the two groups. Like you have the patients who have developed the disease, So you will go back and you will see that why they have developed this disease, because maybe they exposed to some risk factors or they will not. Okay, so that is the point. Okay, then there will be experimental studies. Here the investigator specifies the exposure for each subject, then follows the subjects to detect the effect of the exposure. These are experimental studies. Okay, like you have told that this group has taken some drugs, so you will see in the future that did they develop any problem, like someone has taken methotrexate. Okay, so you will observe them for the next 5 years to see that is it going to cause some abnormality in the babies or not. So that will be an experimental study. So what is a cohort study? Observational study in which outcomes in a group of patients that received an intervention, they are compared with outcomes in a similar group of patients that did not receive the intervention. So involving identification of two groups or two cohorts of patients, one which did receive the exposure of interest and the one which didn't, and the following these cohorts forwards for the outcome of interest. Like one group was smoking and the second one was not smoking, and you are going to observe them over a period of 20 years. So this will be a cohort study. What is a randomized study? Participants, they are assigned by chance to separate groups that compare different treatments. Neither the researchers nor the participants, they can choose which group they are in. So using chance to assign people to groups means that the groups will be similar and that the treatment they receive will be compared objectively. So that will be a randomized study. Then there can be blind assessment. The investigator doesn't know which treatment the subject is receiving. When the subject knows which treatment they are receiving, this is a single blind. And when neither the subject nor the investigator know, then this is a double blind study. So when the patient knows that they are receiving a treatment and the doctor doesn't know, then this is called single blind. But when the patient and the doctor, they both don't know, then it is called a double blind study. Then what is randomization? This is the process of assigning clinical trial participants to treatment groups. It gives each participant a known chance of being assigned to any of the group. So group assignment cannot be predicted in advance. So it removes the possibility that any difference observed between the treatment groups, they are a consequence of a systematic difference or bias between the groups due to a factor that other than the intervention. Randomization ensures similar levels of all risk factors known and unknown in each group. Successful randomization, it doesn't however guarantee perfect balance in risk factors between groups, because there can be something can happen by chance also. Okay, so there are a variety of acceptable methods of randomization, including random number generator and block randomization depending on the sample size. Some methods may result in unequal number of patients in the study group. And methods of allocation such as alternate allocation to the treatment group or methods based on patients' characteristics such as date of birth, order of entry into the clinic or day of clinic attendance are not reliable random and are therefore not acceptable methods of randomization. Then there are certain epidemiological definitions. Epidemiology is the study of disease and the behaviors in a population. What is prevalence? Prevalence is the number of people in a given population affected by a particular disease at a given time as a proportion of the total population at risk of developing the disease. So this is basically a snapshot of all existing cases at a specified time. So that how many people with a certain disease are living in a population. Then what is incidence? Incidence is the number of new disease cases reported in a population over a certain period of time, usually 1 year. as a proportion of the total population at risk of developing the disease. Like there are 1000 people and 100 of them are getting flu, so you will say in 1 year, then you will say the incidence of flu in this population is 100, because 100 new cases have been diagnosed. Then what is a centile or percentile? So any of the 99 numbered points that divide an ordered set of scores into 100 parts, each of which contains 1/100th of the total, then this is called a centile. 50p or the 50th centile means the median. Okay, so some will be above that number and some will be below. So like in the exams, when you are getting the results, they are putting the 75th centile as the passing score. So it means that those who have passed, they are 75, they are 25 points above the center. So what is sensitivity? This is the ability of a test to detect the disease when it is truly present. This is determined as the number of the true positives divided by the sum of the true positives plus false negatives. So true positives, what are the true positive people? Where the test is positive and the patient is also showing disease, divided by true positive and false negative. What is a false negative? The test is negative but patient has symptoms of the disease, so that will be false negative. Then what is specificity? Just remember that other things we were talking about till this point, they were about different studies and how do we interpret them. Now we are these sensitivity, specificity, these are about the tests or about the when we have to describe the test, then we will use sensitivity or specificity. What is specificity? The ability of a test to exclude the presence of a disease when it is truly not present. So the proportion of non-disease patients for whom there is a correctly negative test. True negative divided by true negatives and false positives. What is positive predictive value? This is the probability that an individual with a positive test has or will develop a particular disease, the test is designed to detect. So the true positive divided by all positives. What are all positives? So true positives divided by all positive means that true positives will be divided by true positives plus false positive. So again, positive predictive value of a test. And then what is the negative probability value? The probability that a test with a negative test result actually doesn't have the disease. So it means true negatives divided by all negatives. So it can also be described as true negatives divided by true negatives plus false negatives. Another important concept, what is numbers needed to treat? Numbers of patients needed to undergo treatment to prevent one bad outcome. So this is the numbers needed to treat as compared to the alternative treatment arm or placebo. Numerical representations of the effectiveness of an intervention. For example, the numbers needed to treat to prevent one stroke with aspirin over 2 years is 38. So if you treat 38 people with aspirin for 2 years, one stroke will be prevented that would otherwise have occurred. So if this number is high, number needed to treat is very high, then it means that no benefit of giving certain treatment. Like I will give you one example. If you have many patients who are at 31 weeks of pregnancy and you are giving them antenatal corticosteroids, then at this stage maybe you will have to give antenatal corticosteroids to 80 patients to prevent one case of respiratory distress syndrome to occur. Okay, now you are at 34 weeks, your patients are at 34 weeks, so and then you will give antenatal corticosteroids to 5 patients to prevent one case of respiratory distress syndrome. So It's a better intervention at 34 weeks. That is the point. More premature, you will have to give more it to more and more people to prevent one case of RDS. So going back to meta-analysis, because you are going to see it very frequently. So this is a statistical method of combining the results of a number of studies in an attempt to overcome the problem of reduced statistical power in studies with small sample sizes. So analyzing the results from a group of studies, it can allow more accurate estimation of effects. That is the purpose of using meta-analysis. Correlation, this is the degree to which one phenomenon or variable is associated with or it can be predicted from another one. The degree to which a linear predictive relationship exists between random variables as measured by a correlation coefficient R. It may be positive, but it will not be larger than 1. So if they are going in the same direction, positive, and both are increasing, then you will say that there is a positive correlation. But if there is no relationship or they are regressing, then you will say negative correlation, okay, between the two variables. So both it is positive when both variables they are increasing, or it will decrease together, or negative, but never less than 1. So one variable increases when the other decreases, then or it will be 0. A change in one variable doesn't affect the other, so they have no correlation. Then what is regression? You must have read this term, regression analysis, right? So this is a technique. Yeah. Okay, regression. Mm-hmm. Yeah, because what happens is that your consultant will tell you that we are going to do this study and you will only collect the data, right? You will fill the forms, collect data, and then you will give it to some statistician who will analyze that for you. That's why we don't know much about these tests, while we should be knowing about the basics of statistics. At least, okay, we cannot do the test, but we should at least understand that what is the meaning of a test. Okay, that is important. So regression is a technique used to establish the relationship of a dependent variable and one or more independent variables. Regression analysis attempts to measure the degree of correlation between the dependent and the independent variables, thereby establishing the latter's predictive value. For example, regression analysis could predict your life expectancy by combining your grandparents' age at death and whether you smoke and whether you have a healthy lifestyle or you have a sedentary lifestyle. Then what is a dependent? Yeah, dependent variables like your patient has chronic obstructive pulmonary disease, okay, and the patient is smoking. So you know that if patient is a smoker, then the chances of developing a COPD will increase. So they are dependent variables. Okay. Similarly, you know that if your patient will decrease smoking, then their chance of getting attacks of asthma will decrease. Okay. So these are dependent variables. On the other hand, you have a patient who is taking any diets which has no effect on their disease severity, so these are independent variables. Okay. so, so that is the difference between the variable independent and dependent variables. So what is that statistical power? Statistical power of a study, this is a gauge of sensitivity of a statistical test. Yeah, yeah. Yes, it is like that. Because there is no, so we will, so when you do regression analysis, what you do, then you will, you have like 10 factors in a patient, okay, and you want to see that are they playing a role in the development of PET, then you will see one factor, and then you will realize that no, it has no effect, so you will remove that factor. Okay, then you will go and you will assess the next factor, and then you will find that it has no effect. So in the end you will find just 2 or 3 factors which have some effect on the disease. So by regression analysis, like you are, like if you don't need something in your home, you are going to throw that away. Okay, because you don't need that and it is not helpful. So that is the regression analysis. So in the end you will find something, and you will find some this dependent variables. So that is the point. And then independent variables, that they will have their effect, like if you are, if there is one person, okay, so they are smoker, and they are smoker and they are very heavy, they are obese, so they are likely to develop heart disease. But both smoking has no effect on the, no relationship with obesity. Okay, so both are independent variable. While if the patient is, we say that patient is going to die because of it, going to develop asthma because they are smokers, and then they are obese and they are on steroids, so all of these are bad factors, so they are dependent variables. Okay, that is the point. So it means independent variables means that presence of one factor doesn't, has no effect on the effect of another variable, and they don't have to be present in the patient to develop some disease or some problem. Okay, that is the point. That is the, so like in this case, this is a patient's death is not dependent upon the age of the grandparents, while patient has its own risk factors. And it doesn't say that if the patient had some family members and they died at the age of 50, unless they tell you that we have other relatives, they died at the age of 50 because they were also heavy smokers. So then you can say that this factor is coming into play in this patient also. So you are cutting off the irrelevant things. Is it clear? Is it okay? So what is statistical power? This is a gauge of sensitivity of a statistical test, its ability to detect a relationship, the probability of rejecting a null hypothesis when it is false. So in general, the statistical power increases with your sample size. An index of the probability a study has of obtaining a statistically significant effect. A high degree of 80% or zero point 0.8. Don't be confused by this small number. 80% or zero point 0.8 statistical power indicates that the study, if conducted repeatedly, it would produce a statistically significant effect 80% of the time, if one exists. So on the other hand, a power of only 0.1 means that there would be a 90% chance that the research missed the effect if one exists at all. So this is called power. So then some definitions for you. What is perinatal mortality rate? This is the total number of deaths of a fetus or infant between the end of the 20th week gestation and the end of the 6th day of life in a calendar year per 1000 total births. Just remember, these denominators are very important. Total births, which includes live and stillbirth in the same calendar year. What is neonatal mortality rate? This is the number of children dying under 28 days of age divided by the number of live births that year. Neonatal mortality, that how many children were born alive and how many of them died. Here, this is live births, and in perinatal mortality, you are calculating per 1000 total births. Then what is post-neonatal death? It includes deaths after 28 days of life but before 1 year. What is infant mortality rate? Number of live newborns dying under a year of age per 1000 live births. Then what is maternal mortality rate? This is the number of women who die while pregnant or during the first 42 days following termination of the pregnancy per 100,000 women of reproductive age in a given year for any cause related to or aggravated by pregnancy, but not from accidental or incidental causes. This is irrespective of the gestational age or site of pregnancy. So include ectopic pregnancy also, and miscarriage is also included. So 10th revision of the International Classification of Disease, we use this ICD codes. It makes provision for including late maternal deaths occurring between 6 weeks and 1 year after childbirth. Whenever you are entering the data in the computers, you have to use the ICD codes, so that those who are making these studies or making the hospital census, they will not make a mistake. So maternal deaths, they are divided into direct obstetric deaths, which result from obstetric complications of pregnancy, from interventions, omission, or incorrect treatment, or from a chain of events resulting in any of these. Then there can be indirect obstetric deaths. They result from previously existing disease or disease that developed during pregnancy and that was not directly due to obstetric causes, but it was aggravated by the physiologic effects of pregnancy. So then what is the most common direct cause of death, maternal death? That is venous thromboembolism. And which is the most common indirect cause of venous thromboembolism, VTE, DVT? Okay, that is the most common cause of, before before it was sepsis, but now this VTE has replaced sepsis. Okay, then what is the most common indirect cause of maternal death? That is cardiac disease. So then what about suicide? Suicide has been included in the direct maternal deaths. Okay, they will in your exam. Yeah, not yeah. Yes, it has been included in the direct maternal death. So if they give you in the exam, yeah. So in your exam, you should expect to see stations on perinatal mental health issues, because their incidence is increasing, and now they have included them in the direct obstetric deaths. So that is important for you. You are going to get this station on that. Yeah. Yeah. Yes. Yes. Don't worry, I will take out many things for you. Don't worry about that. I know that that's why I have given you like 2.5 hours on statistics, because you should know how you are going to interpret studies. Two studies will be there. Mhm. It should have worked. Okay, let me check. Let me check that one, and I will get back to you. Okay, because all previous lectures, they are on that page. So let me check. So what happened? Did you click on that and then? Mhm. You couldn't go to the notes or what? Yeah, you try again. Okay, let me send that again to you. Okay, let me check that one and then I will send it back to you. So I've given you the homework, okay, and I will tell you that which resources you are going to use, so that in next session we will practice with statistics, and we will also practice with pre-operative care and early pregnancy complications. I will not give any lecture. I will just test you, okay, because you have to do timed practice. You should be able to finish your station within 10 minutes. Because if you want to get good marks, you should have this should be your practice. You should be able to finish within 7 minutes. Okay, it is still on because nobody will remove anything. Everything will be on the web page. Let me check that again. Okay. Sometimes what happens if there are more people, then it will be stuck. So then close it and then try again after 5 minutes. Okay. Let me check that. Okay. Then take care. Then see you. Then if there is any change in the plan, I will let you know about that. Okay. Okay then. Okay. Thank you. Bye bye.